So now they want us to take this complex number to the fifth. Here is where old things fail, right? We could do this, right? And just do a massive FOIL, and it would take a long time. You'd have to do these and those and then put them together and blah, and it would take a long time. And you're like, wait a second, I've got my binomial theorem. I could use that too. And yeah, you could, but it would still take a while, and then you would still kind of cringe when you saw them ask you for the 12th power, or the very first one to the 20th power, and you're like, no, not going to. But I do encourage you to try it with smaller numbers, like take it to the third maybe, and do it this way, do it that way, see that this is going to work. But polar form's really going to help us here. So if we write this in polar form first, we're 1 on the real and negative root 3 on the imaginary. So 1 on the real, negative root 3 on the imaginary down there somewhere. And again, they love their 45, 45, 90 triangles. So this is a 2, and this is a 60 degrees in there. So I'm just going to keep it in degrees for now. So the radius is going to be 2, and the angle from the x-axis is going to be 300 degrees. And then I could write this number as 2 times the cosine of 300 degrees plus I times the sine of 300 degrees. And so this is another way of writing that. And if I want to take this to the 5th power, my rule says, de Moivre's theorem says, and I can't say his name, sorry, says that all you need to do is take the radius to that power and multiply the angle by that power. So 300 times 5 is 1500. And this is basically your answer. And all you need to do to maybe simplify this is we know that 2 to the 5th is 32. And we know, let's back that 1500 up a bit. So let's take 1500 and subtract 360 a bunch of times, like, I don't know. Oh, cool. So if I go backwards, 1500 is coterminal with 60. If I back it up, subtract 360 4 times, I end up in the same place. So this is totally coterminal with 60 degrees. And that's my answer in polar form. But if they give you in standard form, they generally want standard form, and fortunately we can figure this out. I know that the cosine of 60 is 1/2, and I know that the sine of 60 is root 3 over 2. And then if I just multiply this out, I get 16 plus 16i root 3. And so that was much faster than this, or binomial, or any other method you choose. It's like, wow, that was pretty darn nifty. And the idea that we can multiply, or take this to this power, is just an extension of what we were doing when we were multiplying. Remember when we were multiplying, we said you could multiply the radii and add the angles. Well, this is just multiplying the radius 5 times, so 2 to the 5th, and adding the angles 5 times, so 5 times 300. So it's just a natural extension of the finding the product that we were doing in the previous problems. So fun. There you go.